there's two types of triangles. Okay, so there's, in trigonometry, there's either the right angle triangles, or there's triangles that aren't right angle triangles. So the first thing we're going to look at are right angle triangles, and anytime you see a right angle triangle, you have to think of two things, and those two things are Pythagoras theorem and then your trigonometric ratio. So it's going to be either of these two that you're going to use to solve the right angle triangle. So how do we know that our triangles are right angled? If you look at this diagram down here, when you have that shape there, so a 90-degree angle, your triangle is a right angle triangle. So just to recap on your Pythagoras, it's your hypotenuse squared equals your opposite squared plus your adjacent squared. Don't forget that in your right angle triangle, so your right angle here, this is always your hypotenuse. If you have an angle here, then this is your opposite, and therefore your remaining side is your adjacent. First thing, get in the habit of always labeling your sides. So right angle triangle, the first thing you're going to do is write out your hypotenuse, opposite and adjacent, and go from there. You'll figure out whether you're using Pythagoras or whether you're using trigonometric ratios. You need to learn your trig ratios off by heart. So sine of theta is equal to O over H and so on. There's a little round there. Oliver has a handful of apples because OH is sine, AH is cos, and OA is tan. You need to know that off by heart. So first off, I know I'm flying through this, but I need to fit in. The first thing I'm going to ask, or that we're going to look at, is find AB. So if we look at AB, so that's this side over here, and therefore we know it's this triangle that we're actually dealing with, so which is a right angle triangle. So in an exam, if they give you this, like, a good idea would be to redraw the triangle, but I'm not going to do that at the minute, but you could just redraw it. So you know it's right angle straight away, so you're thinking, okay, I'm obviously using my Pythagoras or my trigonometric ratio, so I'll label it anyway. So 14 is going to be your hypotenuse. There was no angle given, so either could be an opposite and adjacent. So now I've decided whether I'm using Pythagoras or trig ratios. I'm not dealing with any angles here, it's only sides. I know two of them and I want to find the third, so I know I'm going to use my Pythagoras. So I'm going to write down my formula, and I'm going to fill in what I know. So I know H is 14 squared is equal to opposite squared, which I don't know, so I'm going to call that X, and then squared, so I'll call it X. That's going to be plus there, plus 12 squared. So put 14 squared into your calculator, so that's 196 is equal to X squared plus 144. I'm obviously trying to find X squared, so I'm going to try to get that on its own. So I'll have 196 minus 144 equals X squared. So I'll have X squared equals 52. So X is going to be equal to the square root of 52. X is equal to 2 root 13, which is, we'll say, they asked us to 2 decimal places, or 1 decimal place. We'll go for this sake, 7.2 meters. Right, so then we'll look at a different question. So what if they gave us this kind of right angle triangle? So again, we know it's right angle, it has a 90-degree angle. We're using Pythagoras or we're using trigonometric ratio. So the first thing I'm going to do is I'm going to label it. So 17 becomes my hypotenuse, 15 is my opposite because it's opposite the angle here, and they're always like corresponding like that. And then X is my adjacent. Right, so I'm not asking you to find X. If I was asking you to find X, we could use our Pythagoras like we just did there now, but we're asked to find theta, which is the angle. So I'm not being asked to find the sides, it's something to do with angles, therefore I know I'm using my trig ratios. So like, I know H, I know O, and I want to find the angle. So like, think of your trigonometric ratios. Your sine is your opposite over hypotenuse. Your cos is your adjacent over hypotenuse. So I know I have OH here and theta. So I know O, I know H. So that's, I think I will be using sine of theta is equal to O over H, because I can always only have one unknown, and my unknown is obviously going to be my angle in this one. So opposite is 15 and hypotenuse is 17. So there I have one unknown. My unknown is my angle. Sometimes you know your angle and you won't know your opposite or your hypotenuse. Okay, I want to find an angle. So anytime I want to find the angle, I have to get the theta on its own. And the sine crosses equals, it therefore becomes an inverse. So inverse sine of 15 over 17. So it just becomes calculator work. Inverse sine 15 over 17. So to one decimal place, we'll say 61.9 degrees. So theta is equal to 61.9 degrees. Right, then we're going to look at this last one down here. So this has two triangles in one, but for our question we're just going to look at finding PR. So if we kind of outline PR, or like I said, what you can do is redraw it if you like. Right, PR, again, we know it's a right angle triangle. First thing I'm going to do is label my sides. This is my hypotenuse. I'll do them in different colour pens so it stands out. Hypotenuse, this is my opposite because it's opposite the 50 degrees. And then my adjacent is the 17.4 down there. I want to find PR, so I'm going to call it X because that's what I actually want to find. So I'm not trying to find the other side, or I don't know two of the sides, so I can't use my Pythagoras because I'd end up having two unknowns, so I can't do that. So I know I'm going to have to use my trigonometric ratios because Pythagoras will not work for me. This case, I want to find hypotenuse, like that's important. I want to find hypotenuse. I know my degrees is 50 degrees, and I know my adjacent. So I'm going to use cos. So cos of my angle is equal to A over H. You have to like really get to grips at why I picked that. Why didn't I use O over here? Like, why was O not important to me? If I used O, and say I never used the 17.4, if I used O, it would mean I'd have an unknown for O, an unknown for X, and I don't even know my angle. Therefore, that's two unknowns, and I can't solve when I have two unknowns. So that's why I would have figured out, right, I need to find H, I know A, and I know my angle. There's two knowns and only one unknown. So my cos is going to be at 50 degrees is equal to A, which is going to be 17.4, over hypotenuse, which is X. So there I only have one unknown, which is my X. I want to try solve X, so I need to get X on its own. At the minute, X is dividing, so I can't get it on its own, so I have to bring it across and multiply it, because when a divisor crosses equals, it becomes a multiplier. So we'll bring up our X. So that will give us X cos 50 degrees is equal to 17.4. Right, we know that cos 50 is just a number when we put it in. So X, if we want to find X, we want to get X on its own. X and cos 50 are stuck together, therefore we know they're actually multiplying. So if I bring the cos 50 degrees across, it becomes a divisor. Just like our normal algebra, nothing has changed. So into your calculator you put 17.4 over cos 50. And to one decimal place, it'd be 27.1 meters. So then fill in here 27.1 meters. And that's a quick synopsis on how we solve right angle triangles.